Given a system with transfer function like this, and then the question is, design an observer controller for the system to make the system perform 5% overshoot and peak time at 1 second. Okay. So the question can be same with the pole placement controller. I just replace observer controller to the pole placement controller. So same thing. So it means that the type of the question will be same with the observer pole placement controller. Okay. If you still remember that, the process, I write the process here. You have transfer function, you need to convert to the OCF, and then you need to check the observability, and then you need to divide two parts, compensated, uncompensated, and then after that you need to find the L values. Same thing. Okay, that's the process. Okay, so the question gives you transfer function. So what you need to do? Convert to the OCF. Okay. You just use the shortcut way how to convert to the OCF. I think you don't remember. Okay. Because why we need to convert to the OCF? Because we want to apply observer controller. So that's why the transfer function need to convert to the OCF. If you want, in lab number 2, why you need to convert to the PVF? Because you want to design pole placement controller. So that's why in lab number 2, you must convert your transfer function to PVF. Because you want to use pole placement controller. If you want to design pole placement controller by using OCF, automatically it will not working at all. Because I still remember some of the students demonstrate to me, they designed the pole placement controller, and then they got the K value, and then they apply to the state space and the signal flow graph, and then error value, and I check. Why you got the error? And I check again, troubleshoot. Oh, you got error because you didn't convert to the PVF. Your transfer function, you use the original transfer state space. You didn't do the process from state space to transfer function to PVF. He skipped that part. So that's why when they run the simulation, they got error. Cannot run at all. So after I asked them to convert to the PVF first, and then run the simulation according to the PVF signal flow graph, then they get the answer. So that's why it's very important for you to understand that if you use the pole placement controller, make sure you convert to the PVF. If you use observer controller, you must convert to the OCF. Then you can get the answer. Okay? That's the reason lah. Okay. Design observer controller for this. So you have the transfer function, then you need to convert to the OCF. Okay, because I want to save our time, so I will show you directly. Okay. For the OCF, how many order here? Second order. So your metric will be, the dimension is 2 by 2. So if 2 by 2, you only have x1 dot, x2 dot only. You have ax plus with the b, u, y equal to cx plus with the d, u. Okay. I believe you remember how to convert to the PVF. It's very simple. I believe you know that. However, for the OCF, you just need a little bit twist. You just transpose everything. As usual, you just need to, from the transfer function, you need to read from right to left to fill up the A matrix. Okay, firstly you meet what number? Then here will be, for the PVF you need to the right. However, for the OCF you need to the top. So -4, then you meet 5 become -5. Okay. And then you just need to remember this pattern. It should be 0 and 1. Okay, similar with the PVF. But make sure lah, you know, it must starting with 0 first and 1. Okay, for the U, for the PVF 0001 kan. However, for the OCF, you read the numerator part from right to left. Firstly, 10 minus multiplied with 2 you get, or we try to expand it, become 10s plus 20 divided by s square plus 5s plus 4 become 20 kan. So you put 20 first and then go up and then become 10. Okay. So for the OCF, we always need to fill up from the bottom to up. For the OCF, -4 and then -5 up. And then starting with 0, 0 and then 1. And then for the B matrix, we look at the numerator part. We read from right to left, starting with 20 and become 10. And then for the C matrix, it's always starting with 1 and the rest will be 0, 0, 0, 0, 0. Just remember this one. Starting with 1, and because you can see that this is the 4, 5, 1. So -4, 5 and 1. But starting with 1 and the rest will be 0 and D always be equal to 0. Nothing. Okay. So you able now you get the you have the transfer function, you convert to the OCF, done. And then after that, we need to check the observability. This formula also given in the appendix in the final exam to find the observability. No need to remember, must know how to use it. Okay. To get the observability of the system, this is the formula. I believe in the appendix I put C, CA, CA square, CA, CA, and -1. Transpose. Okay, this is in the appendix. I believe I put it in the appendix. Okay. What is the meaning of this one? Transpose. It's supposed to be, because I want, the transpose means actually the real form of the observability is actually C, CA, CA square, CA cube, CA and -1. This is the correct one. Because want to save the space in the appendix. And if I put it this one, it takes a lot of space in the appendix. So if you have 150 students, so I need another 150 pages. Yeah. So that's why in the appendix I put transpose lah. I'm not wrong. This is correct. This is how I can save the space. Okay. So actually this is the correct form. Okay. So don't get confused with that. Okay, so don't put C, CA, CS square. For sure your answer is wrong. Kan? So this is the correct one. Okay. So once again, since this is second order system, so you just need to calculate C, CA, this one? No, because this is second order system, so you just need to calculate two things, to C and CA only lah, because second order. So your observability equation should be C and CA only. Okay, so it means that your C is 1, 0. Your CA is your C multiplied with the A. -5, -4, 0 and 1. Okay. Mana tadi? So finally, what is your CA? 1 multiplied with -5 plus 0 multiply with the -4, you get -5. 1 multiply with 1 plus 0 multiply with 0, you got 1. So finally, your observability matrix is 1, 0, -5, 1. And then you need to find the determinant. I believe you can calculate it straight away. What is the determinant value? Was it 1 kan? But is it correct 1? 1 or what? 1 lah, 1. Because if you still remember that my technique 2T, choose any row or column, 1 and 0, and then close here, and then you get 1. This one you need to calculate it. Everything multiplied with 0, you get 0. And then apply positive and negative, apply positive, negative, finally you get 1. So 1, is it equal to 0? Which is not equal to 0, then the system is observable. Okay, since not equal to 0, so the system is observable. If for placement, we say that controllable. In observer controller, we name it as a observable. Something like that. Everything about the term lah. Can we apply observer controller now? Yes or no? Yes. Are you sure? Why? Yeah, that's the answer. Okay. So the system is observable, so we can this done. Okay. So only how many? Two steps only lah. Adalah. Okay. Can I proceed? Oh, boleh habis awal ni.